Aloha champions, and welcome back to another science video. We've been talking about energy, motion energy, how two objects that are moving collide, transfer energy, and how the transfer of energy can create some unique things for us. So today in chapter 6 of our reading, we are going to be learning in particularly how can energy transformations solve problems. So up until this point, we've been thinking like scientists, thinking about understanding and learning new phenomena. Today, we're going to be thinking like engineers, people who are problem solvers, and how we can solve problems in our world through energy transformations. Okay, so our big question for today is, how do energy transformations help people? How can the transfer of energy from one thing to another thing help us as humans? Okay, so before I get into the reading, let's look at this problem here. You want to heat bread to just the right temperature. Yeah, toasting to the right level of golden brownness is always important. But how do I do that? How do I go about solving this problem of heating my bread up? Well, the solution is the toaster can change electrical energy to heat motion and sound energy, and the toasty bread pops up, ding, onomatopoeia, at just the right time. So a toaster transforms the electrical energy that has traveled all the way from a power plant to create heat and sound energy. And all that heat energy gets transferred into the bread in the toaster, and once it's hot enough, it will release the toast and make a big ding to tell you that your toast is golden brown. Okay, so the problem is, I want toast. The solution? Use a toaster, and it will use the energy to make things better. Okay, so without further ado, I'm going to get into reading through chapter 6 today. Remember, at the end, there will be 5 to 10 questions to answer in Google Classroom to make sure that you understand the reading. Imagine living in a time before toasters. It's a scary time. You want to toast a piece of bread. You hold the bread over a fire, but the fire gets hot. But over the fire, it burns too quickly. Now you have burnt bread. This is a problem, a real problem. Suppose you need to meet a friend in the morning, but alarm clocks have not been invented yet. So you're going to be late, and your friend leaves without you. This is a problem. Burnt bread, friends leaving because we can't be timely. These are problems that need solutions. So engineers are people who use science and technology to make things that people want or need. They're problem solvers. They help us to solve problems. To an engineer, anything that people want or need presents a problem to be solved. So if people need it or want it, there's clearly a problem that we have to solve. Okay? All kinds of problems can be solved through the design of new devices. Toasters and alarm clocks are devices that help people. And many such devices are designed to make use of energy transfers or transformations. Okay? So solving problems requires understanding energy. In finding solutions to problems, engineers consider the properties of energy. They know that energy can transfer or move from place to place or through contact to contact. As a bowling ball collides with bowling pins, some of the ball's energy of motion is transferred to the pins. Your score goes up, problem solved. Problem being, I want a better score in bowling, so I throw the ball, it knocks over the pins, I get a higher score. Engineers also know, as do you, that energy can transform or convert from one form to another. When a bowling ball collides with pins, some of its energy of motion, its kinetic energy, converts to sound energy as the surrounding air vibrates. Such conversions occur when energy changes from one form to another. People use what they know about energy changes to design and build devices that make use of these energy transformations. These devices can make life easier, more productive, or even just more fun. Sometimes we need more fun in our lives. So here we had 3 brand new vocabulary words. I'm going to take a quick moment. They were big and bold there. I want to double check my vocabulary box here to make sure I understand what those are. So I have convert, to change form. So if energy converts from motion energy of my hands to sound energy of my clap, it is converting that energy, okay? The second new word for us is conversion, the process of being converted or changing form. So the energy is undergoing a conversion when I clap my hands from kinetic or motion energy to sound energy. Okay. The last one we have for a vocabulary box is energy transformation, the change of one form of energy to another form of energy. Okay, so energy transformation only applies to energy transforming. To convert, you can convert other things other than energy. But for the sake of this, we can use to convert or a conversion interchangeably with energy transformation. They're changing shape, one form to another, okay? All right, our next problem here is you need to know what time it is. I always take off my watch when I'm working on my iPad because it scratches up the screen. I don't know what time it is. So the solution is mechanical clocks use springs to store energy. So all the springs, they're tightly wound up and they've got a lot of energy to them. They transform stored energy to motion energy. So when they move up and down, they move, and the moving clock hands show people the time of the day, okay? So the solution can be found in a mechanical device that engineers came up with to tell the time. All right, on to page 33. Transforming motion energy can help solve problems. People need electrical energy to power all sorts of devices. Even more each day. I seem to keep getting new things that need to be plugged into the wall. But where does all this electrical energy come from? Most of the electricity we use in our homes comes from the transformation of motion energy to electrical energy. In 1831, a scientist named Michael Faraday discovered that moving magnets past copper wires in certain ways produces a flow of electrical energy through the wires. He discovered a way of transforming motion energy to electrical energy. Okay? So many engineers have used Faraday's discovery to build generators, rotating devices that convert motion to electricity. Hydroelectric dams and the turbines on wind farms use the movement of water and wind to rotate generators. The spinning motion in the generators is converted to electrical energy. So a word to know, it's not quite a vocabulary word, but it's separated in this box, so we should spend some time here. Rotate means to spin. For example, blades of a ceiling fan rotate around and around to make the air move in a room. So your hands spinning like this, they are rotating. You spinning around on your chair, you're rotating. Rotate, the verb of moving side to side or spinning around an axis, okay? So here's a model of a generator based off of Faraday's example. we have a coiled copper wire here in the middle. The motion energy from either wind, water, or an engine can spin the rotor of the generator, and these magnets along the outsides read the copper wire spinning inside, and it produces electricity. So the problem that engineers saw was that people need electricity to power many of the devices they use. The more energy, the more devices we can use, the easier our life will be. The solution that engineers like Faraday came up with is to come up with generators that convert motion energy from spinning parts to electrical energy. Because it moves, it creates electricity. That electricity can be used to make our lives easier. Thank you, engineers. All right, page 34 here. Transforming stored energy can help to solve problems. Batteries, which we talked about in a previous one where you had to think, why do batteries lose power? Batteries provide electricity too. Batteries are made of chemicals that have stored energy or potential energy. The stored energy in a battery transforms to electrical energy. In turn, that electrical energy can be transformed in useful ways by many other devices. Some batteries die after all their stored energy has been transformed to electrical energy. Other batteries can be recharged. Rechargeable batteries can convert electricity from a wall socket to a stored chemical energy for later use. Rechargeable batteries are especially useful for small portable devices, such as your cell phone. People want to carry some electronic devices with them wherever they go. These electronic devices use energy transformations in several ways. For instance, a cell phone, for example, converts stored energy in its battery to electrical energy. The electrical energy from the battery transforms to sound energy when you're listening to Spotify, or when the phone rings or voices come through the speaker. That's all sound energy. It also creates light energy when the screen displays pictures or videos. You're always staring at light when you've got your phone in your hand. And it can be motion energy when the phone is set to vibrate for certain notifications. Okay? So the problem is that people want to be connected to others wherever they go. We're social creatures. We want to communicate to each other. We want to not be stuck in a classroom all by ourselves talking to a camera and recording this. We want to communicate and teach. So a solution that engineers came up with is that smartphones with rechargeable batteries store electricity and transform it to sound, light, and motion so that we can stay better connected with other people. Page 35, transforming light energy can help solve problems. Solar cells are made of material that transforms sunlight to electrical energy. The transformation of energy from sunlight to electrical energy also happens on a very large scale. Solar panels convert sunlight to electrical energy during the day. Some of that electrical energy can be stored in batteries to power useful devices at night when the sun is not out. So the solar energy, the sun heats up the solar panels, and the solar panels take that and convert it into energy, storing it in a battery to be used later. For instance of how solar energy can be used to make our lives easier, this solar pad that can charge this phone's battery can be small and portable. A bigger solar panel can convert more sunlight to electrical energy. It can provide electricity for a home that does not have access to electricity generated by a power plant, or by people who want to have their own energy and not pay the bills of the electricity. If you have enough solar panels in a sunny region, like in Arizona, can provide all the electricity needed by an entire community. It doesn't have to be hot to be sunny. So just because Arizona is super hot with all the sun we also get a lot of sun and very little cloud cover, so solar energy could work wonders here. Or you don't even have to be on Earth for it to be sunny either. Solar panels solve the problem of how to get the electricity needed to operate the ISS, or International Space Station. Okay? So, engineering design solves problems. Engineers solve problems. Okay? All the devices that you have just read about transform energy. They have something else in common too. They were developed using a process called engineering design. Engineering design is used by scientists and engineers to develop solutions to problems. Engineers are problem solvers. Our new vocabulary that just popped up, engineering design, over here in the vocabulary box, is a process used to develop a solution to a problem. So anytime you have a problem and you need to create a solution for it, you are engineering design. Okay? The process starts with identifying a problem to be solved. I want my bread not to be burnt. I want to communicate to people who are far away from me. I want to power and save up energy cheaply. Okay? Teams of scientists and engineers determine a want or need that the design is going to meet. Then they judge possible solutions by how practical they are and how well they solve the problem. It might take hundreds of attempts to try to fix something, but if it doesn't fix the problem, or if it's not practical, it costs too much, it weighs too much, people aren't going to use it, and therefore it's not going to solve our problems. They got to keep solving problem after problem after problem. For example, electric cars must have rechargeable batteries that store a lot more electrical energy than your cell phone battery. An electric car battery must store enough energy but not be too heavy or too expensive, or else nobody's going to drive it. Designers have to consider things like cost and weight to solve problems without creating new ones. You don't want to overthink or over-engineer a problem and realize you've got a whole lot more problems that you need to work on. Okay? Engineers who design electric cars must also design charging stations. Well, before the electric car, we didn't have the Tesla stations where you could park your car and plug it in to transform electricity to stored energy in the car's battery. They had to think of multiple things because by creating the electrical car, they created a problem that there wasn't enough places to charge your car where you needed it. All right, that will bring us to the conclusion of Chapter 6 for today and how engineers are problem solvers using the conversion of one form of energy to another to help make your life easier. And with that being said, have fun answering the 5 to 10 questions, stay awesome, and I will see you real soon.